In this video, I want to talk about relative minimum values and relative maximum values. Sometimes instead of relative, you see the word local. So local minimum or local maximum values. And I think that is sometimes what makes it sink in a little better intuitively. What I'm looking for is a spot on the graph that looks like a mountain peak for a relative maximum value. It doesn't have to be the highest point on the graph. In fact, on the thing I have graphed over here, we keep going this way, so no point would ever be the highest point. But I only need it to be the highest point in a little space of the function, a local space. And so if I look right here, I think there's a relative maximum value right there. Right, it looks like the top of a hill. Right, relative maximum values look like tops of hills. Relative minimum values, they look like, the bottom of a valley instead, and I think I have one right here. It's not the lowest point on the graph, that goes down forever, but it's the lowest point near that point, looks like the low bottom value, and that is a local or relative min. Well, let's take a look at the definitions of these terms, and then see if we can do one more example together. A function value, f of a, that's a y value. A function value, a y value is a relative maximum, and I've abbreviated here, relative max of f, if there exists an open interval containing a, all right, so f of a is the y value, a is the corresponding x value. You plug in an a, you get out an f of a. So that f of a is larger than every other y value, f of x, for all x not a in that open interval. Well, if I look over here, right, I can find a little open interval on the x-axis. And if I look at all the y values just from here to here, that's the largest one. That's a relative maximum value. A function value, f of b, is a relative minimum of f if there exists an open interval containing b, so that f of b is less than f of x for all x not b in that open interval. So again, if I can just look at a little part of the x-axis and make this be the smallest y value, the lowest point just in that little blue region, then that is a relative min. And what we could say is these relative extreme values, the maxes or the mins, they occur at an x, and the relative maximum value is the y value. The relative minimum value is the y value. So let's take a look at an actual example and see what that looks like. So I have a function here called y equals g of x, and I want to find any local or relative extreme values. And when I say extreme values, that just means relative, mins, or maxes. Either one. So extreme value, just a way of saying minimum or maximum all at one time. Well, let's see if we can find the relative mins. All right, well, I'm looking for anywhere that looks like a little valley bottom, a low point in the graph. Well, I see two of them. And I need to remember the relative min itself is the y value. So the relative min of minus 2 occurs at x value. 1, 2, 3, minus 3. So the relative min of minus 2 occurs at minus 3. Over here I have relative min of minus 1, and it occurs at 3. I'll pause the video here and see if you can locate where the relative maximum values are. All right. Let's find those relative maximum values. I see two mountain peaks, two tops of hills to find. And this one, let's see, that's 1, 2, 3. So the max of 3 occurs at 0, right? X equals 0. And then there's a maximum of 1, 2, 3, 4, 5. And that occurs at 1, 2, 3, 4, 5. 5 happens at 5. The max is a y coordinate. It happens at an x coordinate. And I should probably use all the words here. Min of minus 2, a minimum of. And I could even go say a relative minimum. Relative maximum, and say all of the things I could possibly say. The big thing to hold on to is minimums. They're the bottom of a curve, just near that point. Maximums are the top. The max or min is a y value, and it occurs at an x value.